Good morning everyone. In this episode we are going to see using Cramer's rule solve some problems we are going to see, then area of the triangle. Then in this chapter I have told you that we are going to study two more types of matrices, that is singular and non-singular matrices, and to find A inverse. Let us move on to this episode. Before that, if anyone did not subscribe my channel, please do subscribe and press the bell button. Let us move on to this episode. First question, using Cramer's rule, solve the following. First subdivision, 5x plus 2y is equal to 4, 7x plus 3y is equal to 5. So first x coefficient is a system of linear equations. Cramer's rule, to find the unknown variable x, y, delta x by delta, delta y by delta, to find the value of x and y. So first of all, to find delta, you have to take the determinant. Delta is equal to determinant coefficient of unknown variable, that is 5, 2, 7, 3. Taking determinant of coefficient of unknown variable, that is 5 3s are 50 minus 7 2s are 40. So determinant value is equal to 1. This are now delta x is equal to determinant. In place of coefficient of x, I have to replace d1 and d2, that is nothing but 4, 5, and remaining as it is 2, 3, that is 4 3s are 12 minus 5 2s are 10. So 12 minus 10 is nothing but 2. Delta x value is 2. Now delta y is equal to determinant. In place of coefficient of y, I have to replace d1 and d2. So that is 4, 5. I am writing first. The remaining elements as it is. That is 5, 7. That is 5 5s are 25 minus 7 4s are 28. That is 25 minus 28 is nothing but minus 3. That is nothing but delta y. Now to find x value, y value, that is x is equal to, as per Cramer, to find the unknown variable x is equal to delta x by delta. That is nothing but delta x is nothing but 2 and delta value is 1. So the value of x is nothing but 2. Value of x is nothing but 2. Now y is equal to delta y by delta. And delta y is minus 3 and delta value is 1. Answer is minus 3. Therefore, the value of x is equal to 2 and value of y is equal to minus 3. Is it clear? For 2 by 2 matrix, easily you can find out. For 3 by 3 matrix, is a task. Is it clear? We will do that. Go through this. Second question, subdivision B. X minus y plus 2z is equal to 7. 3x plus 4y minus 5z is equal to minus 5. 2x minus y plus 3z is equal to 12. Now, here the unknown variables are x, y, z. That means you will get determinant of 3 by 3 matrix. Determinant of order 3 by 3 matrix. First, our task is to find delta. To find delta, delta is equal to determinant coefficient of x, y, z. That is 1, minus 1, 2, 3, 4, minus 5, 2, minus 1. How to find the value of determinant when the order of the matrix is 3 by 3? Expanding with respect to first row, alternating plus minus. So that is 1 into determinant, including this row and this column I have to eliminate. So 4 minus 5 minus 1 3 plus, so plus minus plus. So plus 1 into, how minus and minus is plus. So plus 1 into 3 minus 5 2 3, then plus 2 into what? 3, 4, 2, minus 1. Yes or no? So that is 1 into 4 3s are 12 minus. Minus into minus is positive. So 5 plus 1 into 3 3s are 9 plus 5 2s are 10, because minus 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 will be positive, plus 2 into minus 3 minus 8. Yes or no? Now 12 plus 5 is 7. 12 plus 5 17 plus 9 plus 10, that is 19 into 1 is 19, plus 2 into minus 3 into minus 3 minus 8, that means minus 11, minus 22 you will get. minus 22. So the value of the determinant is nothing but 7 plus minus 3. 7 plus minus 3. That is nothing but 4. Determinant value is 4. That means delta value is 4. Next, you have to find out to find delta x and delta y and delta z. So to find delta x, that is delta x is equal to determinant. In place of coefficient of x, I have to replace what? D1, D2, D3. That is 7 minus 5, 12 remaining as it is. Minus 1, 2, 4, minus 5, minus 1, 3. So expanding with respect to first row, alternating plus minus, you will get the value of delta x is nothing but 8. Similarly, delta y is nothing but determinant. In place of y coefficient, I have to replace d1, d2, d3. So 7 minus 5, 12. Remaining x coefficient and z coefficient are same. So here 1, 3, 2, 1, 3, 2, 2 minus 5, 3. So after expanding with respect to first row, alternating plus minus, you will get the value of delta y is 4. You will get delta y is nothing but 4. So delta z is equal to determinant. So in place of z coefficient, I have to replace d1, d2, d3. That is 7 minus 5, 12 remaining as it is 1, 3, 2, minus 1, 4, minus 1, minus 1, 4, minus 1. So after expanding delta z with respect to first row, alternating plus minus, you will get the value delta z is nothing but 12. Now to find x, y, z, x is equal to, Gabel has introduced that x is equal to delta x by delta, y is equal to delta y by delta, and z is equal to delta z by delta. Delta x by delta. How to find delta x? Delta x you have already answered, 8 by 4. So 8 by 4 is nothing but 2, and delta y is nothing but 4. So delta value is again 4. 4 by 4 is nothing but 1. Now delta z is nothing but 12. 12 by 4 x is 3. So the value of x is equal to 2, value of y is equal to 1, and the value of z is equal to 3. Is it clear? Is it clear to everyone? Just to go through this. Is it clear? Next concept, area of the triangle. Area of the triangle whose vertices are x1, y1, x2, y2, x3, y3 is given by delta is equal to half into modulus of determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. That means here I am taking all the 3 points in two-dimensional plane. That's why you have x coordinate and y coordinate. If it is 3-dimensional plane, you will have z1. So far I am not going to discuss about that. We are going to take area of the triangle in two-dimensional plane. That's why x1, y1, x2, y2, x3, y3. And why here modulus came? Because area never be a negative. That's why here modulus came. Is it clear? So area of the triangle whose vertices are x1, y1, z1 and x2, y2, z2 and x3, y3, z3 is given by delta is equal. That means here also we are finding the determinant is equal to 1 by 2 into modulus of x1, y1, 1, x2, y2, 1, x3, y3, 1. If it is a three-dimensional geometry, you will get x1, y1, z1, 1, x2, y2, z2, 1, x3, y3, z3, 1. Is it clear? That means order of 4 by 4 matrix you will get. Is it clear? Is it clear to everyone? Now, for example, these are only 3 points. We have to find the area of the triangle using this concept. So here x1 is minus 2, y1 is minus 3, x2 3, y2 is 3, x3 is minus 1, y3 is minus 8. So substituting by delta is equal to 1 by 2 into modulus of determinant. x1, y1, 1. So minus 2, minus 3, 1, 3, 2, 1 minus 1 minus 8 1. Very important concept, area of the triangle. So 1 by 2 into modulus of determinant. I have to expand for 3 by 3 matrix. How? Expanding with respect to first row, alternative plus minus. So minus 2 into directly I am going to do minus 2. 2 ones are 2 minus 8 into 1 minus 8. So this will become plus. So minus 2 into 2 plus 8. So plus minus plus. So minus into minus will become plus. So plus 3 into 1 3s are 3 minus 1 into 1 minus 1. So it will become plus 1. Now again plus 1 into minus 8 into 3 minus 24 minus 1 into 2. So minus into minus again plus. So plus 2. Is it clear? Is it clear? So that is 1 by 2 into modulus of. So now I am taking modulus of. Now this line becomes modulus of 8 plus 2 10 minus 2 minus 20. 8 plus 2 what? 10 into minus 2 is minus 20. Now 3 plus 1 4 3s are 12. So plus 12. Now minus 24 plus 2, that means 2 minus 24 is minus 22. So minus 22. That is 1 by 2 into modulus of minus 20 minus 22 minus 42. Yes or no? Minus 42 plus 12. That means 12 minus 42 minus 30. So minus 30. Modulus of minus 30 is what? 30. That is nothing but 30 by 2. That is 15. Don't write only 15. Since you are finding the area, you have to write 15 square units. That is 15 square units since area. Is it clear? Is it clear to everyone? So area of the triangle whose vertices are x1, y1, x2, y2, x3, y3 is given by delta is equal to half into modulus of determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. Why here modulus came? Since area cannot be a negative, that's why modulus came. After finding the answer, you have to write square units. You have to write square units because since this area we are finding. Is it clear? Just to go through this very important concept, area of the triangle. Next concept, singular and non-singular matrix. I have told you that in this chapter we are going to discuss two more types of matrices, that is singular and non-singular matrix. Why I am discussing in this chapter? Because this singular and non-singular matrices depends upon the determinant value. If a matrix capital if a square matrix capital A is said to be singular, determinant A is equal to 0. So the value of determinant is equal to 0, then the given matrix is singular matrix. If the value of determinant is not equal to 0, then the given matrix is said to be a non-singular matrix. So a square matrix capital A is said to be a singular matrix if determinant A is not equal to 0. And if a square matrix capital A is said to be a non-singular matrix if determinant A is not equal to 0. That means we cannot say for every matrix is singular or not singular. For every square matrix only we can say that whether it is singular or not singular. That means if you want to define a singular matrix or not singular matrix, the matrix has to be a square matrix. That's why you can find the determinant, right? See, if you want to find the determinant, the matrix has to be a square. That's the same condition. If you want to define a singular matrix or not singular matrix, the matrix has to be a square matrix. Is it clear? So, once again I repeat, a square matrix capital A is said to be a singular matrix if determinant A is equal to 0, and if the square matrix is capital A is said to be a non-singular matrix if determinant A is not equal to 0. One important note for this definition is there. If A and B are two non-singular matrices I have two matrices which is non-singular. That means determinant A is not equal to 0. Then AB and BA is also a non-singular matrix. Then product of AB and product of BA is also a non-singular matrix. That means determinant of AB is also not equal to 0. Determinant of BA is also not equal to 0. That's what they are telling in first note. Is it clear? Then the second note is determinant of AB is equal to determinant A into determinant B. So this is the theory part of singular and non-singular matrix. Let us go through with example. For example, capital A is equal to one matrix I have 1, 2, 3, 4. Check whether the given matrix is singular or not. How to find singular? Determinant A is equal to 0 or not. So I have to check. So first, determinant A is equal to determinant 1, 2, 3, 4. What is determinant value? 4. 4 minus 6 is nothing but minus 2. Yes or no? Are they 0? No, which is not equal to 0. That's why this matrix is non-singular matrix. Is it clear? This matrix is non-singular matrix. Now one more example I have. So 0, minus 2, 0, 3. This is another matrix. Capital M or capital S, whatever you can take. Capital M is equal to. So find the determinant of this one. So that is 3 zeros are 0. Minus 0 into minus 2, that is 0, which is equal to 0. So now you got the determinant of M is nothing but 0. So this matrix is nothing but singular matrix. Is it clear? This is the way you have to check whether the given matrix is singular or non-singular matrix. Is it clear to everyone? So I repeat, if you want to find out a square matrix is said to be a singular or non-singular, determinant A is equal to 0 for singular matrix, determinant A is not equal to 0 for non-singular matrix. Is it clear? Is it clear? Just go through this. Okay. So far, in this episode, we have discussed problems on CRAMER'S rule, area of triangle in two-dimensional using determinant, then singular and non-singular matrix. I suggest to understand the theory part, then move on to the problems. If anyone did not subscribe my channel, please do subscribe and press the bell button. We'll see the next episode. Thank you.